Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Welcome to the Enterprise Networking Security and Automation version 7 curriculum, module 2, single area OSPFv2 configuration. In this video, we're going to be talking about OSPF router IDs, how to configure them. We're also going to be configuring a single area point-to-point OSPFv2 network. We're going to talk about multi-access OSPF networks. That will be bringing up like the designated router and backup designated router configurations and how to modify priority information. We're going to talk about how to modify a single area OSPF, how to implement those changes as well. We're going to talk about default route propagation, and we're going to talk at the end about verifying implementation of OSPFv2. So let's go ahead and let's jump right in. Let's talk about OSPF router IDs. So in this figure, we look at 3 routers. We see that they have the appropriate networks. This is a 10.10.1.0 network. This is a 10.10.3 network. This is a 10.10.2 network. And they have the appropriate subnet mask, or the networks and subnet masks between the routers. But in this network, there is no static routing, there is no dynamic routing, there is really nothing. So all the interfaces on R1, 2, and 3, except the backbones, should be within the OSPF area. The ISP router is used as a gateway of last resort, but this is going to be the sphere of our OSPF. You'll notice it says Area 1. This is not in our gray color because this is outside the sphere of our Area 0 control. So how do we configure OSPF? You do router OSPF and a process ID. Here the process ID is 10. That is basically just a way of denoting what all the routers will be using for their OSPF. And you'll notice that it is best practice to use the same process ID on all of the routers. So once you configure router OSPF, then you can notice it takes you down to the sub command, router tac or config tac router, and here's all the options we get. We're going to be configuring network statements in a little bit. Passive interfaces we'll discuss a little later in this video, but then we have this router ID. The router ID for this OSPF process allows us to configure our priorities using router IDs. So an OSPF router ID is a 32-bit value represented as an IPv4 address. It's used to uniquely identify the OSPF router and all of the packets, including the router ID of the originating router. So it's basically a way for us to flag what the router will be designated as. Each router requires a router ID to participate in the OSPF domain. It can be defined by the administrator or automatically assigned by the router. The router ID is used by the OSPF enabled router to do 2 big things. Participate in the synchronization of the OSPF database. This is basically during the exchange states. The router with the highest router ID will send the database descriptor packet first. So again, the IDs will matter. Also, the ID allows the router to participate in the election of a designated router. If we're assuming a multi-access LAN environment, multi-router environment, the router with the highest router ID will be elected the designated router. The one with the second highest ID will be the backup router. So if we want to designate which router will become the primary or the designated router, we would set a higher router ID on that device. That allows us to dictate what device will get the designated router process. Alright, so router ID order of precedence. the router ID is explicitly configured using the router ID command. That would allow it to go first. The router will choose the highest IPv4 address of any configured loopback address. So if you don't manually configure a router ID, the router will choose the highest loopback address. If there is no router ID command issued and there's no loopback address, the third choice would be the router will choose the highest active IPv4 address of any of the physical interfaces. So router ID, if that doesn't happen, it will look at loopback. If that doesn't happen, it will look at physical address. And it's going to take the highest of them. And again, the purpose here is the highest IP address will become the designated router or the primary router within the OSPF environment. So that's the process for router ID selection. So how do we configure a loopback on a router? We do interface loopback, give it a number, and we treat it like a interface. So if we do a show IP protocol, we will get a router ID of our loopback. If we want to explicitly configure a router ID, underneath OSPF router and the process ID, we could issue a router ID command, and it will do that first. So what happens if we do a router ID under OSPF and we also do a loopback? Again, that order of operation, explicitly stated router IDs under the router OSPF process ID first. Next will be loopback. Next will be physical interfaces. So if router ID is configured underneath the first option, it will ignore the other options. So whichever one it comes across first with the router ID, that becomes the router ID. So again, understanding the order of operations there is kind of important. So how do we modify a router ID? So you can always clear the IP or the IP OSPF process, and then you can modify it. You can modify it, but once the router is processing the OSPF, the new router ID will not actually be updated. So you have to do the clear IP OSPF process to actually clear the process or restart the process to refresh the router IDs. So moving on, let's talk about how to configure OSPF in a point-to-point network. So again, OSPF or router OSPF, give it a process ID. That gets us to our config TAC router. Then we need to issue network commands. It will be network, the network ID, the wildcard mask or the inverse of the subnet, the area, and then the area ID. If we're talking a single area OSPF, this should be area 0. That's pretty common. The area ID syntax will refer to, the OSPF area. If we're talking single area, it would be 0. If we're talking multi-area, which we'll talk later in this video about that, it would be a different area. So again, the subnet mask is going to be, let's say, a /24, so 255.255.255.0. The wildcard mask is the inverse of the subnet mask. So /24, 255.255.255.0, the inverse would be 000.255. If we're talking a /26, again, I don't know why the diagram is like that. A /26 would basically take the 26 ones, and the remaining ones would be 6 zeros. You flip all the ones to zeros, you flip all the zeros to ones, and that would be your inverse. Again, inverse is just a clever way of saying take your subnet, and the opposite of the subnet would be your inverse or your wildcard. And that is how we get our network and wildcard masks. So here we have our 3 network statements. This will be whatever networks are attached to that router. So earlier we had our connections between routers 1 and 2, routers 1 and 3, and we had our LAN. So 10.10.1.0 was a /24, so the inverse would be 0.0.0.255. So again, that's how we do our calculations for our wildcard masks. And you would do that for each of the routers. You can also explicitly state what the addresses are with a wildcard mask of straight zeros. Basically, it says use that specific interface, so whatever IP address that is applied to that interface, that will be the interface processing those OSPF commands. That basically just says you don't have to worry about the wildcard masks, so you can do quad zeros. Realistically, you should get used to doing the wildcard masks, and you'll notice these are the specific addresses of those interfaces, not the network IDs. So let's try to put this together as a whole. How do we configure OSPF? Again, OSPF, we would do the network statements, or we could do the network statements underneath the interfaces. So here we have a ISPF or IP OSPF process ID. We could give it an area, and we would then navigate to the different interfaces. So you'll notice here we have one for our loopback, our gig 001, and our gig 000. So you can do the OSPF underneath each interface, or you can do it underneath a explicit router statement. It just kind of depends on what you want to do. So you do not need to do the network statements if you're doing it underneath each interface. But if you do it underneath each interface, you need to make sure to do it underneath all of them. By default, OSPF messages are forwarded out all OSPF enabled interfaces. So even if you do not want it to send OSPF updates out of the LAN, by default it will. The problem is, by sending it out all interfaces, sending it to the LAN, for example, that is a higher security risk. Also, sending it out all interfaces is an inefficient use of resources and bandwidth, because again, the LAN doesn't really need to receive those updates. The fact that the LAN could get an update means the LAN could also respond. So if you have a malicious person on a LAN, they could send router updates if the OSPF is listening on that LAN interface. So we have what's called a passive interface, basically saying do not send or receive updates on this interface. And you normally will do that on LAN interfaces. So how we do that is basically say passive interface, and you give it whatever interface you do not want to send updates to. Normally, you do not want to update the loopback, and you do not want to update the LAN addresses. You can now verify by doing a show IP protocols command to verify which interfaces are passive. And you'll notice here, show IP route, it will show us the information like router ID, maximum paths. It will show routing on the interfaces explicitly, and it'll also list where the passive interfaces are located. Here we only have the loopback as passive. So we can also then look at further details by show IP OSPF, going to the appropriate interface, and you could drill down on additional information that way. You can see things like its designated router ID, the interface ID. You can see what its current router ID is, its backup ID. So from this information right here, we can tell that this is our router ID, and you can tell that we are the backup designated router because that's our router ID information. So again, show IP OSPF interface gives us details specific to those interfaces. To change this to a point-to-point network using the interface configuration command, we could do an IP OSPF network point-to-point on all of the interfaces where you want to disable the designated router, backup designated router election process. If it is just a point-to-point, like between a one router and another router, and there is no additional connectivity or an additional connection there, you can set just a point-to-point, and you could do that underneath the interfaces. So again, interface gigabit 000 IP OSPF network point-to-point, that disables the designated router, backup designated router election process. Thus, you don't have to worry about it consuming resources. It consumes resources because this is done via a broadcast. So let's go ahead and let's talk about the use of loopbacks to provide additional interfaces for a variety of purposes. To simulate a real LAN, you could use a loopback interface. So if you do a show IP route and include our loopback address, you can. We can see that when R1 advertises its loopback address, that is what we're getting. We're getting that /32. So if we configure a loopback interface and we configure it as a point-to-point connection, then we will actually get the appropriate subnet mask. Because again, by default, the loopback interfaces are advertised as a /32. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.